Okay, so the second part of that, um, you have the brackets, then you have the numbers from 0 to 9, then you have the letters from A to F, and that will match it says it will match any single hexadecimal digit, like 7 or F. Um, and the important part is single. So you're just looking for one character. Um, okay. Then I'm on page 56. This is where it gets interesting because instead of having to type out all the numbers or all the letters, that dash symbol is a special symbol in regular expressions. So far we've seen that the brackets are special symbols, that the dashes are special symbols, that the dots are special symbols. And so the what the dashes represent is basically it will fill in the gaps. So 0 dash 9 will be all the numbers between 0 and 9, which is a handy shorthand. Um, you know, A through Z, same thing. Um, and again, because it's in brackets, you're only looking for a single character to match any of those. Okay, so uh, if you want to look for special sets like digits or words or spaces, or it says word characters here, but in Ruby it would we would just call them characters. We have the backslash D for numbers or digits, backslash W for regular characters, backslash S for any white space character. And then you have the pipe symbol, which is the just the operator that just looks like a line going up and down. Um, that is used to say either the left hand side. I want to match on either the left hand side or the right hand side, and these can be a single character or it can be words.
Uh, Also, I don't know if there. I remember working with Perl, and there's a like kind of. I don't know if it's in Ruby is the same stuff. I don't recall using, but like the slash D is for digit number, but the slash D in all caps are like non-digit numbers. Are these the same stuff?
Yeah, it's the
Like,
same.
yeah,
So
okay.
yeah,
So
Ruby
some
Ruby has inspiration from Perl, and it uses the the same regular expression protocol as Perl. So
okay,
anything that you could do in Perl, you can do in Ruby.
that's good.
Okay, so I'm on page 57 now, where we're looking for those. Uh, we have the backslash dot, uh, and remember the backslash means the literal dot. Um, and so, it matches on A dot M dot or, P dot M dot or PM. Um, okay, so um, there's a sentence there that says the car or boat is red. So those parentheses are basically saying, okay, we're gonna either match on the whole word car or we're gonna match on the whole word boat. So either one of those is going to be a match. So the car is red or the boat is red. They both match. Anything else will not match. Um, Yeah, the regular expression star. Now we have another symbol, the star. Um, there's there's multiple names for this star. There's star, there's asterisk. When you're doing bash programming or something like that, they might also call it the glob character. Um, those are all the same names for this star symbol. So so basically, what it means is that we're going to match any like if you see the first example here, A, B, star will match an A followed by, well, that sentence says only by one B, but it's it's any number of B's. So it's going to be a single B. It's going to match on 10 B's. It's going to match on 0 B's. Um, so when you see that star, it's basically saying, you know, I'm expecting either a B to be here or nothing, or yeah. Um, okay, I'm on page 58 now.
And if you want, like, you can put like a number into parentheses and define how many views you want, right?
Yeah, I forget the syntax for it. Is it parentheses?
No, I
Yeah.
think it's brackets. I think.
Yeah, you can define like the number of bees. You can be very, very specific about how many bees you're looking for. You can also use, and I think they talk about it later, but the plus operator would be the another option to use if you're interested in more than one bee. So you use an asterisk when you say like it's okay if there's no bee here. You use a plus to say no, looking for at least one bee. Maybe I'm going to accept more than one bee, but there needs to be at least one bee here for the plus symbol. Um, okay, so moving on to page 58, the expression AEIOU star will match any of the number of vowels. Um, right, so like like we learned earlier, the brackets denote, hey, I'm looking for at least one of these characters. Oh, it looks like we lost them.
Yeah, I think so.
So we're looking for any of these characters, and then the star says, and normally we would match only one of, we would just be looking for uh, the zero index of the string to match any of those one characters. But because we have the star there, it's basically saying any number of these will match.
Yeah,
Yeah, likewise, the expression, uh, likewise, the expression 0 through 9, star will match any number of those digits. So, like normally, we would only be looking for one of those digits, but now we can say, okay, any set of numbers is okay, even no numbers, because we're using that star. Um, okay, so the dot star is special. Like the dot is basically saying anything in this zero character place. And then the star is saying, uh, I want any length of that. So the dot star is basically saying matches everything. And by everything, I mean digits, I mean characters, I mean symbols. It'll match everything. Um, okay, so I'm going to move on to the next section, regular expressions in Ruby. In Ruby, the regular expression, or regex for short, is one of the built-in data types. Yeah. So uh, the format that a regular expression takes is that forward slash, and it always ends in a forward slash. There's also options that you can put. They don't explain the options here, but let's say you have forward slash at the beginning, a forward slash in the back, and then you put an I there. It means I want this regular expression to be case insensitive. And I forget all there's case sensitive, there's case insensitive, there's other options for you to use after the last backslash. And that's why, you want a regular expression cheat sheet or a website that lists all the possible options for regular expressions because they're a little hard to remember if you don't use them all the time. Okay, so you have the special equal, was it tilde operator, which is basically performs a pattern match. So on one side, you're going to put a pattern, a regular expression pattern, and on the other side, you're going to put a string. And the order of that doesn't matter, I think. I think you can put the pattern on left or right.
Yeah.
Um, so and that's basically will let you know if you've found a match on that regular expression. Um, that match, so I'm on page 59. Uh, the first match the first example that it puts there where it has the regular expression for a time and AM PM, and then on the right hand side it has 10:24 PM. Uh, it prints out zero. That zero is trying to tell us a few things. First, it's saying that the regular expression matched and that the starting index is zero. Now, if you're coming from like a C based language, that zero usually means false. Uh, but in this case, in Ruby, when you're using the pattern match expression, it doesn't, zero doesn't mean false here. It means it found a match and that match was on the zero index. Um, I think if it doesn't find a match, it returns nil
Yeah.
for no index. Yeah.
Yeah.
Okay, and then the second example, it's you're looking for the regular expression of PM, and it finds that regular expression on index 6 of the of that string literal. Um, oh yeah, okay, so so forward slash May back forward slash uh, sometime in June. Since there's no match there, it does return nil. Okay, great.
Mm.
Um, okay, yeah, the equals tilde operator is ambidextrous. It doesn't matter the order, so you can put the string in the front. Yeah, okay. Um, okay, beginnings and endings. Oh, A? Okay, so this one I'm not familiar with. I'm on page 60 in the section beginnings and endings where it
Okay.
says once upon a time. And it says if you want uh, If you want to make sure that it starts at the beginning, there is a special symbol for that, and that is \A. Um, I wasn't familiar with that character. When I use it, I usually use the caret operator, which is the symbol above the number six.
Mm.
Uh,
Yeah, I think in the next pages they go through the different
Yeah, you
thing
talk
that
about
we,
it.
yeah, the slash a, because I was familiar with the card as well.
okay.
Yeah, so I think what it's about, I think he talks about it in the next pages. He gives you four options. So you have a forward slash and an A, which is less specific compared to a forward slash and that symbol you've talked about that is above the number six. And I think the difference comes in with the forward slash A only checking for if there's a string at the start of the content block. Like now, let's say if I'm checking for once upon a time, it only returns, it only matches if once upon a time starts that content block, as opposed to this symbol you've talked about, the one that is above the number six, which can match if you have once upon a time at the start or anywhere within the content block. I think that's a difference, and it's kind of a similar thing when you're dealing with the forward slash Z and then the dollar sign symbol. I
Yeah.
don't know if that makes sense. Yeah.
Yeah.
He talks about it in the following pages. Yeah.
So yeah, I don't know if it talks about it here, but in addition to the A and the caret symbol, there's also another one that does something similar, but is a little bit different, which is is the symbol that looks for a word boundary. And I forget the symbol for that. But a word boundary being like, okay, you have a space here, you have a word, then a space, then the start of another word. And I want to make sure that whatever I match is at the beginning of a word so that you use the word boundary symbol. Okay. Then it gives you an
Yeah.
example of where it's used, and it's used in time.rb, and they're doing regular expression matching to match on some times in that method called zone offset.
Yeah.
Um, some uh, I mean, it's used a lot of different places. Um, Staying out of trouble. Okay. Uh, page six. I'm on page 63. So the first example on page 63 is the regular expression. It's forward slash ABC star forward slash and then equal equal and then the string ABCCCCC. And it's trying to tell you that like, you know, uh, 99 times out of 100, you're using the equal equal sign. And
Yeah.
so that's completely ingrained into you. So it's very, very easy instead of writing that tilde to write another equal sign. And it's going to happen a lot just because you're not thinking about it. Your fingers do the work. So
Yeah.
it's going to happen. Um, oh yeah, this is where it goes into the zero. So
Yeah, the one
if
you talked
you're,
about.
yeah, we talked about it. Okay,
Yeah.
so wrapping up. Okay, that's the end of chapter 5. Um, when you're working with, well, first of all, it's when you're looking at somebody else's regular expression code, it's really, really hard to understand, especially if it's a very, very long regular expression. Um, and sometimes like expressions are not the only tool that you can use to parse things. You can write a parser instead of writing a regular expression. And even though it's used to parse out natural language in a lot of places, um, regular expressions really are intended to be used on regular language, something like XML, which has definite rules that it needs to follow. Because when you're working with strings that don't have any rules at all, um, it's very, very easy to write regular expressions that are wrong. Um, Also, just as a practical sense, there are websites out there where where you can put in regular expressions and you can put in pattern or so you can put in strings and you can put in regular expressions and you can see if they match or not. And it makes it a lot easier to interactively work with regular expressions or create the irregular expression in the first place. Um, because you can interactively see what matches and what doesn't and play around with the different options. Um, in my own experience, I've stumbled on this problem as well, where I was trying to. Um, Hold on. So I was trying to parse out demographic information with one of the pieces of demographic information that I was working with was Asian, right? Like that was one of the strings that I found. But I wrote the regular expression wrong because it also matched Caucasian. And so you have to be really, really careful when you're writing these regular expressions. Um, I had to go in there. Yeah, it looks like what I used was backslash B, and backslash B stands for the word boundary. And so checking for the word boundary and then Asian made sure that um, the word Asian didn't get lumped into Caucasian. Um, but a parser, what a parser would do would be it's a different way of it would have been a different way of parsing this information. And basically, you're going to, instead of using a regular expression, you'd go in and tokenize all your elements so that you have um, your individual strings into individual things, and then you can start working with your individual tokens. They have semantic meaning. When you're doing natural language parsing, some of those tokens are going to have meaning like, oh, this is a noun, this is a verb, this is this is a pronoun or whatever. And you can start tokenizing those individual elements into something with semantic meaning. Um, and when you're working with language that doesn't have regular rules or it can have surprises, that can be a better option than regular expressions. Okay, so I think the next chapter is somebody else. Chapter 6.
Yeah, I'll breeze through the next chapter. So I'm going to reference this first bit of code. I don't know. It's so I'm going to reference this symbol that says A equals and then a symbol of all. And then we are trying to see if B is equal to A, and then we also equate C to the same symbol. Have you found the page in the book?
What page?
I'm not sure about the page. I don't know. You guys might be using a physical copy, and I'm not. I'm using a soft copy.
Yeah, I have the PDF. It's at
Mm.
the top and top of the page.
I think it's in the subsection named optimized to stand for something.
Oh, okay. So that's page
Yeah,
67.
that's the code I'll be referencing. So we see that we have a symbol, and the symbol is all. If I'm trying to read it out, and it's been equated to the letter A. So as part of this chapter, what we are trying to see is where is a symbol supposed to be used, what function is it serving, and where is a string supposed to be used, and what function is it serving. And what the author tries to bring out here is that now let's say, for example, for the all symbol, we have three characters. If we were to create a string and it's also of the value all, like we open the double quotes and we say ALL to spell out the string, that string and the symbol are like serve very different purposes when it comes to different contexts. So he talks about a string and using a string only if you want to store data for something that is supposed to have an operation performed on it. Remember, I think in the previous chapter we talked about the string API and the methods that come inbuilt with it. I think gsub and the whole truncation thing, dot uppercase, lowercase method. I don't know if you guys remember those. So all these methods that are provided by the string API will allow you to perform operations on the string to change the data. And that is the main point he tries to bring out. You use a string when you want to store data. So which takes us to a symbol. What do you use a symbol for? A symbol should be used to stand for something. And this is because of two qualities of symbols as objects in Ruby. First and foremost, symbols are immutable. That means you can't change a string, no, a symbol, sorry. Which brings me to the code on this page. We are trying to see if, now let's say we are trying to check if B is equal to A, whereby we define A is equal to a symbol and then B is equal to A. So if we're using the operator that allows us to equate, we'll see that these two are going to return, like they are going to be referencing the same object. And therefore A will be equal to B and will be equal to C because they'll be pointing to the same object. Now, let's say this was a string instead of a symbol. That won't be true. A will not be equal to B and B will not be equal to C. And neither will A equal to C because they are not pointing to the same object. So this is one of the qualities of a symbol, is that it's immutable. It can't be changed. That is, even if you say A is equal to this symbol and B is equal to the same symbol, A and B will refer to the same symbol. Yeah. And then the other quality is that a symbol is unique. At any one time, if you define a symbol, and that symbol is kind of similar to what we have on this page, there will only be that symbol, that only symbol, that exact copy of the symbol at that point. You can't have another symbol that is like that one. So the symbol is unique. And because of these two qualities, the immutability and the uniqueness, that is a quality of symbols. It is because of these reasons that symbols tend to be used as hash keys, whereby you open a hash and you have a symbol as a key and then the value. It is because of those two qualities. And then he talks about the interchanging, whereby you can call the toSym method on a string to change it into a symbol. And then you can also call I think the toS method or the toString method to convert a symbol into a string. But
Cool. 30 seconds.
it, Oh, in summary, that is what the chapter is trying to bring out. Where do you use what and where? Where is the symbol supposed to be used and where is the string supposed to be used? And why is this used in this position and why is this used in the other position? Thank you. Yeah.
Okay. Let's see you guys
See you
next
guys.
Friday.
Okay. Thank
Yep.
you for attending.